Okay, so we are on to our last lesson in Chapter 6. We're going to be solving radical equations and inequalities. One of the things we've done before this is we have solved polynomial equations, like x equations, x squared equations. So a lot of the things that we know from doing that will help us in the lesson that we're doing right now, as well as some new stuff that we know about radicals. So solving radical equations, we're going to go back and forth between, I'm going to give you the steps, and then we're going to go through example 1, kind of following each step as we go. All right, so first step, and this step is very, very, very important, we have to isolate the radical on one side. Okay, meaning on one side of the equation, all you have is something that's under the main square root. All right, so let me show you with example 1, part A. So for example, I have the square root of x minus 2, but then I have this little plus 1. So in part of isolating, I have to move that plus 1 over. All right, so add 1 to both sides. Now I have 6 on the left, and then I have the square root of x minus 2. All right, so get the main square root by itself on one side of the equation. That's what I mean by isolate. All right, step number 2, raise each side to the power of the index. To eliminate the radical. Okay, so remember the index is whatever the square root or the cube root or the fourth root, and so you raise to that power. So the one example that we're looking at, we've got a square root, which means the index is 2, and so we raise both sides to the power of 2. That step means if it was a cube root, you raise both sides to the third power. If it was a fourth root, you raise both sides to the fourth power, etc. All right, so we're going to clean this up. So 6 squared we know is 36 equals, and then what happens over here, like we said in step 2, it eliminates the radical because the square root, then squaring, those two actions, I guess, cancel each other out. And we're left with an x minus 2. Okay, so our last thing that we're going to do, step 3, is we need to solve the resulting polynomial equation. All right, so polynomial equation, this is a pretty simple one. All we're going to do is we're going to add 2 to both sides here. Okay, so we end up with x equals 38. Okay, so now in this step, in step 3, it is incredibly, incredibly important that you check your answer when we're doing square root functions, okay, or cube root functions or whatever else it is that we're doing. Incredibly, incredibly important, okay? So, of course, I, for some reason, don't have a calculator on me, but I am going to walk you through the process, just how you'd plug it in by hand, and then in class we can talk about how you would do it in your calculator, the little true-false check. So if we plug in 38, and we're going to do a little check over here. So we want to see if 5 equals the square root of 38 minus 2, and then outside minus 1. So we've got the square root of 36 minus 1, and so we can check that. Square root of 36 is 6, and then minus 1 does in fact give us 5. So 38 seems to check out. All right, so in this step it is very, very important that you check. We've talked about extraneous solutions before. I just want to get an official definition down for you guys. An extraneous solution is a result, so like the 38, but it's a result that doesn't actually satisfy the original equation. Okay, so it's like, you do all the algebra, you do the algebra correctly, yet for some reason it just doesn't end up checking out when you try to plug it back into the equation. So 38 worked. It checked. Let's take a look at part B. Okay, so step 1, isolate the radical on one side. Now there are 2 radicals, but this is like the main radical, the bigger one, the one that has more stuff underneath it. So that's the one you want to isolate. Step 2, raise each side to the power of the index. So raise each side to the second power. So we're doing that right now. So on the left-hand side, the big square root and the squared just cancel each other out, and we have x plus 15 equals, and then on the right-hand side, because of the addition in the middle, we actually have to FOIL it out. Okay, so this is kind of a weird example. When you have a square root on both sides, you have to do this. Okay, so we're going to FOIL the right-hand side. 5 times 5 gives us 25. Then we have 5 root x plus 5 root x. So for outside and inside, we get 10 root x. Then I have root x times root x. The square root of x times the square root of x leaves me with just an x. Okay, and then on the left-hand side, I have an x plus 15. So that's where I'm at so far. Next thing that I'm going to do is kind of look around at some of the pieces. I have an x on both sides, so if I were to subtract x from both sides, they would just end up canceling out. Okay, so I want to get this moved over because I'm kind of going to walk through the steps again. Now I'm going to isolate this radical on one side. So 15 minus 25, I get a negative 10 equals 10 times the square root of x. Isolate the radical, so I'm going to divide both sides by 10. These cancel. I have a negative 1 on the left equals the square root of x. Last thing is I'm going to raise both sides to a power of 2. So I get just an x when I square this, and then negative 1 squared gives me positive 1. So that's the answer that I come up with. Let's check our answer by plugging into the equation. So square root of 1 plus 15. We want to know if it equals 5 plus the square root of 1. Alright, so 1 plus 15 is 16, square root is 4, equals 5 plus square root of 1 is 1, so that's 6. Obviously, 4 does not equal 6, so that means this one doesn't work. So if you ever come up with an extraneous solution, leave it written, leave all the work written, just put a big X through it to show that you've done the check to see if it works, and it turns out it doesn't. So that's how we demonstrate that we came up with an extraneous solution. Okay, example 2. This one is in a slightly different format. You've got the 1/3 power instead of the cube root, but remember they are the very same thing. We're going to follow these same steps. You're still going to isolate the radical on one side. So we're going to start by adding this 2. Okay, then I have 3, 5y minus 1 to the 1/3 power equals 2. Still working on that first step where we isolate the radical. So I'm going to divide both sides by 3. These 3's will cancel. I have 5y minus 1 raised to the 1/3 power, and then I have a 2/3 on the right-hand side. Alright, so that's all part of that first step, isolating the radical. Now remember, 1/3 power is technically the cube root, so that's really the radical in this area. Then I'm going to raise both sides to the power of the index, so I'm going to raise both sides to the 3rd power, because this time I have a cube root, not a square root. So raise both sides to the 3rd power. So these will cancel out, because really what happens here is I multiply them. I multiply 1/3 times 3, and I get a power of 1, which means it's just the 5y minus 1. And then when I cube this fraction, I cube the 2, which gives me 8, and I cube the 3, which gives me 27. Okay, now step 3, solve the resulting polynomial equation. So I'm going to do whatever I need to do to get this y by itself, which first involves adding 1 to both sides. I get the 5y by itself, and then this is the same thing as adding 27 over 27, because that's 1, just a fancy one, and it gets me the same denominator as this. So I add the 8 and 27, it gives me 35 over 27. And then the last thing to do is divide both sides by 5. Instead of dividing this fraction by 5, I'm going to multiply it by 1/5. Okay, so last thing is the 35 over 5 will reduce down to 7 over 1, and then I'm left with 7 over 27. Okay, so we're hoping that's our answer. Let's double check our answer really quick. Slightly ugly answers here. This would probably be a nice one to have a calculator for. Okay, so let's start from the inside. Alright, so on the inside here, the 5 times 7 over 27 gives us 35 over 27, minus 1 to the 1/3, and then minus 2. We want to see if it equals 0. 35 over 27 minus 1 is really 35 minus 27 over 27. So as we know from over here, we end up with 8 over 27. Okay, 8 over 27, if I take the cube root, that's what it means to raise to the 1/3 power. Cube root of 8 is 2. Cube root of 27 is 3. And then minus 2. Okay, so now I think we've made it here. So 3 times 2/3 is 2, and then 2 minus 2 does give us 0. So that means that this answer checks out. It's not extraneous. It's an answer that actually works for us. Okay, so since we're cutting these notes in half, we are just doing one more quick problem right here. Okay, so this one's a multiple choice. So we're going to walk through the same steps, but we have options. So we'll know for sure if our answer is right once we get to it. So step 1, isolate the radical. So I'm going to start by adding 12. Then I have 4 times the 4th root of 3x plus 6 equals 12. Still working on that first step of isolating the radical, so I'm going to divide both sides by 4. These will cancel. I get the 4th root of 3x plus 6 equals 12 divided by 4, which is 3. Okay, so that's the first step. The radical part is by itself. Second step is to raise each side to the power of the index. So here the index is 4. So to undo a 4th root, you have to raise to the 4th power, which means I do the same to the right-hand side. Okay, so those two cancel out, remember, and I get just a 3x plus 6. 3 to the 4th power, we've seen this the last couple lessons, gives me 81. Okay, then I will subtract 6 from both sides. Just the 3x remains. 81 minus 6 is 75. And last step, I'm going to divide both sides by 3 to get x by itself. So I end up with 25. All right, since I have a multiple choice, I know that that must be my right answer. Okay, it's a nice quick lesson for you.